effort towards that. And you must be wondering now, I'm talking about atmospheric brown cloud and I'm showing what air pollution is. So what is all about? It's about air pollution containing aerosols. This is very important in ABC. And what the aerosols are is of soot and dust that absorbs and as well as scatters the incoming solar radiation. Incoming solar radiation is like the radiation, that the heat what you receive from the sun. So what they do is they scatter. I'll show you how it does. And leading to the, why it is important, because it leads to the regional and global climatic effects, posing risk to even climate, even to your health, and ultimately to the atmosphere and food security issues. So you must be all coming from the flights, and this is not a very good season because this is a rainy season, so the skies are either cloudy or it's clear. So when you are traveling during the dry season, when you see this from your plane, you can see these type of haze layer, the orange, the beautiful.
I'm shocked to know that there are no rainfalls in Pakistan, but whenever we enter into the Pakistan, other Pakistani girls might agree with me that we have such type of situation in Pakistan. We cannot see anything down there when we go through the flights. So it's all over the Pakistan.
Yes, yes, it's all over South Asia. Actually, it's like a size of US continent, means Pakistan, Bangladesh, India, Nepal, Bhutan, though it's very pristine. But mind it, like its air has no boundary, you know, it gets transported. Yeah. So, you know,
And it starts at like after a few hundred feet.
Yes.
Yeah, after a few hundred feet when the flight just take off and then we see nothing down there.
Yeah. And yeah, this especially happens also in the pre-monsoon season when this is, the situation is more aggravated, you know. Yes, it has two effects that I'll come a little bit further. So I just wanted to show you that what their components is SO2, O3, NO3, NOx, and black carbon is also in this aerosols. So I'll come about, like you mind it, SO2, NOx, BC. So ozone is also there, ammonia, CO is also there. So I'll talk about a little bit on the heating and cooling effect in my another slide. But I'll first tell you what aerosol is. Aerosols, they are like, you know, they're not bad. They have to be in the air. Otherwise, like, you know, these are water vapors. When they're in a pristine, like in clean environment, their size is like that. We get more of water in this. But when it's in the polluted environment, you know, you have, in the same area, you have more of this, you know, aerosols, but the size is smaller. Because the size is smaller, so more can accommodate. But here, the size is big and less can accommodate. This is in the normal cloud, this is in the polluted cloud. So you have lots of this. So what happens? This is the reason of all the climatic implications that aerosol does, which I'll come a little later. And I just wanted to show how they are. These are the clouds, and then, you know, you from the households, your pollution is going, and these are from the sea, the sources of aerosols. Sea salt is also a natural form of aerosol. So from the water vapors, when you sit, like you are in the beach, you can see that sprinkles, you know, that is also a type of aerosol which has more of sea salt. So these are the sea salts, and these are the, you know, pollution. So what it does is you first saw the big particles. When these particles are inside, then they absorb the water inside from these aerosol particles. So they become smaller and smaller, and that is the reason why you see the hazy environment. That's what Kamran has mentioned, like you cannot see anything because you can just the hazy environment. So that is because of this impact. Then coming to your cooling and the heating impact. Like, you know, I have mentioned like SO2, NOx are there in the aerosols. So these are like scatters the reflection, because these are bright particles. So what this thing is like about when you are wearing a white shirt, you know, it reflects the sunlight. Then you feel your body is more cooler. And the same analogy, like when you are wearing a black dress, it absorbs. So the black carbon is a black particle which absorbs. But sulfate nitrates are the what particles? Light particles which scatters away the light. So same analogy here. When you have a sulfate nitrate, it backscatters and cools the environment. And when it's the black carbon BC component, it absorbs and warms this whole layer, because it's not up in the troposphere, it's in the above atmosphere. And what it does, it warms this layer, and it doesn't send the heat downstairs, so that it dims the whole surface. And then, you know, that I show the polluted ground, it cannot form, like, you know, to make rain, like these aerosols has to collide and fall as a rain. But when you have these polluted particles in the aerosol, what it does, it just, you know, have this Brownian movement, and it cannot form into a rain, so that it just has a hazy, you know, atmosphere, and then the rainfall is suppressed. So this is about the whole impact of ABC. It has the warming effect and it has a cooling effect. So it's the surface is cooled, the top layer is, like, you know, heated up, and the whole climate system is like disrupted because of this.
Can you explain it again, please? It's really important to.
Okay. You know, did you understand, anybody? In aerosols, I showed you, like in the clouds, in the aerosol there are sulfate particles, NOx particles, black carbon, and other components as well, NH3. And ozone is not a primary pollutant, but it's formed of mixing with other NH3 and O2, then it forms ozone, NO2 plus O2, then it forms ozone. That's a secondary pollutant. But these are all, black carbon is primary pollutant, SO2 is primary pollutant, NOx is primary pollutant. So they are in the atmosphere. They come from different sources, like NOx, they come from vehicles, black carbon, from biomass burning, SO2 from industries, from bricklins. So these are the components that are coming from all these sources, and then they go up, and then in the aerosols, they have these components. So what happens is, when the aerosols have this, when they are having black carbon, it absorbs it. No, that like the black dress you are wearing, it absorbs it, and this layer is whole warmed, because they are absorbing heat and they are not letting it down. And when you have sulfate and nitrate particles, what they are in the aerosol, so what they do is they scatter it, and there's a surface cooling, and you know, the layer is here also, the layer is warming. Because of this cooling effect, it is said, like, you know, the amount of heat that has to be generated, like if there was greenhouse gases, they had calculated the planet should be warmed by this much degree. Because why it's not warming is because we have sulfate particles and nitrate particles that are cooling the atmosphere. But now, what scientists have come up is, like, there's another particle which is also heating the atmosphere. But heating in a different sense, you know, they are heating this layer. That is black carbon. So, you got it? Without cooling, the amount of, like, the greenhouse gases we are putting into our environment should have, like, much more heated our planet. But because of the sulfate and nitrate particles, it's minimizing the cooling impact. But now we have this black carbon particles, which is also heating it, but it's heating it at this layer. And the other also I'll come up when I'm talking more about black carbon. So what it does is, when you have, more pollution, then the aerosols, that big aerosols, they are smaller in number, so they cannot form into a rain. The aerosols is like, 90% of water vapors. So when you have these polluted things in the aerosols, then the water is like, around 10% or 20%. So all the water is being sequestered by these particles. If you can do an experiment. You can put a drop of water and carbon particles, ash or something like that. You just take it near that particle, and what it does, it absorbs water. So it's the same analogy.
I have a question. I want to know about that. Is there any role of the global warming potential of each, like SO2 or NOx?
SO2 and NO2 is more of a cooling type of thing. That's why it's, I said, like, the amount of greenhouse gas we have put into this atmosphere, we would have heated this earth much more. But with this, like, it's cooling. But global warming is there because due to black carbon. It's around now, they have calculated around, like, greenhouse gases is around 70% and 30% contribution is coming from black carbon.
Along with the greenhouse gases, black carbon?
Carbon, yeah. But for the warming. And these are, like, transported from, and they have done a trace element study, and they have seen that these can, within weeks to days, they can travel throughout the globe. So it's, I said, like, air doesn't have any boundary, and though you see, like, your country is very clean, but it can come from elsewhere according to the wind direction. And this is from indoor, from urban to regional, and it's become a global issue. Now coming to the black carbon, BC. I said, like, one of the component in ABC is BC. Now we are much more worried of this component present in the ABC. Why? Because I said, like, 30% of the warming is due to the black carbon particle. How it does is, what is it? Is a climate forcing agent, is climate, what is adds to the climate through, and it's formed through the incomplete combustion of fuel from activities such as fossil fuel combustion, biomass burning, biofuel burning, cooking and heating purposes. So whatever you do, like the agricultural waste burning, the cooking that you do in a home with biofuels, so that adds to, that leads, like, if you are, having a campfire, you see these soot particles, black particles. So that is black carbon. And it's not like, produced by humans only. It's also naturally produced. Can you give me an example? Yeah, volcano. And other one? Forest fire. Yeah. Good. So these are, like, it's not in our hand. Volcano, in the last volcano, the Iceland volcano, there was a huge economic loss because of these particles, and the visibility was not there, and they had to cancel these flights, and there was a huge economic loss. This is not in our hands. That is natural. So, and what are the primary source? They are from the diesel engine, from the cook stove, wood burning, and forest fires. And why it is important? I said, like, in the earlier slide, it's absorbing